Now we are going to move towards next concept, that is orthogonal set and orthonormal set. So idea of this sets is easy, okay, and I'll just take few examples, then you'll understand. So let V be an inner product space. A subset S of V is said to be orthogonal. तर एखाद्या इनर प्रोडक्ट स्पेसचा जो सबसेट असतो त्याला आपण ऑर्थोगोनल कधी म्हणणार, जर कोणतेही दोन डिस्टिंक्ट वेक्टर्स त्या सेटमधले घेतले, जर त्यांचा इनर प्रोडक्ट जर 0 येत असेल तर आपण त्या सेटला काय म्हणणार, ऑर्थोगोनल सेट. आणि सपोज इन ॲडिशन टू दॅट जर दोन डिस्टिंक्ट वेक्टर्सचा जर इनर प्रोडक्ट 0 येत असेल आणि दोन सारख्या वेक्टरचा जर इनर प्रोडक्ट 1 येत असेल तर त्या सेटला आपण ऑर्थोनॉर्मल म्हणत असतो. आय होप यू गॉट द meaning of orthogonal and orthonormal set. So remember that every orthonormal set is going to be orthogonal, but every orthogonal set need not be orthonormal. करेक्ट? कारण की ऑर्थोगोनल सेटमध्ये काय असतं, दोन डिस्टिंक्ट वेक्टरचा इनर प्रोडक्ट 0 पाहिजे आणि ऑर्थोनॉर्मलमध्ये काय, दोन डिस्टिंक्ट वेक्टरचा इनर प्रोडक्ट 0 पाहिजेच आणि इन ॲडिशन टू दॅट दोन सारख्या वेक्टरचा इनर प्रोडक्ट, म्हणजे आता ती सारखी म्हणजे दोन म्हणणं चुकीचं आहे, आणि सारख्या वेक्टरचा इनर प्रोडक्ट काय पाहिजे, 1 पाहिजे. दिस इज द मीनिंग. ओके. and if I want to give example of the orthogonal and orthonormal, let me give you few examples. Yeah, so let us see this. For example, V is equal to R2, and suppose my set is containing these two vectors, that is 1 1 and 1 minus 1, and inner product is the usual dot product. So if you take two distinct vectors, now there are since only two vectors in this set, so we'll check what is the inner product of 1 1 with 1 minus 1. So if you find out the inner product, it will be 1 multiplied by 1 is 1 plus 1 multiplied by minus 1 is minus 1, and this is equal to 0. So you can see that the inner product of two distinct vectors comes out to be 0. So definitely it is an orthogonal set. So is it an orthonormal set, that we have to check. So now, so we will check inner product of the vectors with itself. So we are supposed to check two things, inner product of 1 1 with 1 1 and inner product of 1 minus 1 with 1 minus 1, and if it comes out to be 1 in both the cases, then we will say that it is orthonormal also. But what we will get, 1 plus 1, that is nothing but 2, and over here you will get 1 plus 1 again, which is 2. So inner product of vectors, distinct vectors is 0, but inner product of vector with itself is not 1. Okay, so therefore it is not a orthonormal set. Okay, so not orthonormal, but it is orthogonal. Okay, now let me take one another example, the second one. I will keep my vector space to be R2 only, and I will take my S to be some 1 upon root 2 comma minus 1 upon root 2 and 1 upon root 2 comma 1 upon root 2. Simply what I have done is I have divided the vectors by its norm, that's it. Okay, so first vector was 1 1, right? So if we calculate the norm, you will get it to be root 2. So therefore my vector will be 1 upon root 2 1 upon root 2, and similarly the norm of this second vector is also root 2 only. So simply the set is same, simply what I had done, I had divided the vectors from that set by its norm. Now I hope you already got the trick that how to check whether it is orthogonal set or orthonormal set, so I leave it to you. Now one can easily find that this is going to be orthogonal set, you can check it on your own. But what about the orthonormal condition? So definitely it is going to be orthogonal. You verify it, that inner product of this element with this element is going to be 0 only. We will call them as u and u. Now let us check the inner product of u with u and inner product of v with v. If both comes out to be 1, then we will say that it is orthonormal set also. So what will be inner product of u with u? It will be inner product of 1 upon root 2 minus 1 upon root 2 with again what, 1 upon root 2 with minus 1 upon root 2, and this will be exactly equal to what, 1 upon root 2 multiplied by 1 upon root 2 will be half, and again plus half, that will be 1. And similarly you can check that the inner product of v with v will be also 1, therefore it is an orthonormal set. Okay, so it is both orthogonal as well as orthonormal. Okay. Now let us go towards the next definition, that is orthogonal basis and orthonormal basis. So we already know what basis is. So there is no much difference between basis and orthogonal basis. Now we have already understood what is a orthogonal set. Okay. So a basis set, you already know that basis is nothing but one set. So if that set is a orthogonal set, in addition to that, if S is a basis and if that set is orthogonal also, then we will say that that basis is a orthogonal basis. And if the set is basis and suppose that set is orthonormal also, then it becomes what? Orthonormal basis. So definition is simple. A basis S of a inner product space we said to be orthogonal oblique orthonormal if S is a orthogonal oblique orthonormal set. Okay. So now let us see few examples where we are supposed to check whether the given sets are orthogonal sets or not. Now in case of two vectors it is easy to check, just we have to check one inner product. But whenever you are having three vectors in our set, our task increases, because what does the definition of orthogonal set say? The inner product of any two distinct vectors should be equal to 0. So over here we are supposed to find three inner products. Okay, which inner products? Inner product of 1 with sin x we have to find, inner product of 1 with cos x we have to find, and the next one is inner product of sin x with cos x we have to find. If all these three inner products comes out to be 0, then we will say that it is an orthogonal set. And if एक जरी inner product जरी यातला non-zero आला, then we will say that it is not a orthogonal set. Okay, then let us do it. So let us first of all find out the inner product of 1 with sin x. So now here inner product of 1 with sin x is equal to integration minus pi to pi. 1 multiplied by sin x is sin x dx. What is integration of sin x? Now derivative of cos x is minus sin x. So integration of sin x will be minus cos x. So minus cos x, limits will vary from minus pi to pi. And you can use some formulas also if you know it. In analysis, have you learned it? If you are having a integration from minus a to a f of x dx, and if function is odd, then this integral is directly 0. If it is odd, it is 0. And if the function is even, then it is twice integration 0 to a f of x dx. So if this formula is known to you, you can use it, and yeah, you can calculate it. As you know that sine is a odd function, so whatever you do, you are going to get it to be 0 only. Now let us go for another one. Now okay, integration 1 with cos x will be equal to integration minus pi to pi cos x dx. Since cos is a even function, it will be twice integral 0 to pi cos x dx. Now integration of cos is going to be sin x, so twice sin x, limit will vary from 0 to pi, which will be equal to twice sin pi minus sin 0. But as you know, sin pi is 0 and sin 0 is also 0, so this is going to be equal to 0, because the what are the zeros of sine? That are the n pi, means sin pi, sin 2 pi, sin 3 pi हे सगळं zeros असतं. And what about the inner product of sin x with cos x? The inner product of sin x with cos x will be integration minus pi to pi sin x multiplied by cos x dx. Now one is odd function, one is even function. The product of odd and even is again odd. You treat even function as 1 and odd function as minus 1. Okay, so you know the product 1 multiplied by minus 1, the minus 1 is na, and minus 1 stands for odd function. So product of even and odd is always odd. So it is odd function, so integration is going to be 0 only. So what is your conclusion? Yes, the given set is orthogonal. Now the same thing you can do for this set S, and this I'll leave for homework. So that's all about unit number 3. So we have near about covered all the important topics from unit number 3. So whatever topics we have discussed, so if you are having any doubts in that topics, so you can either call me or you can ask me on WhatsApp also. So that's it, we'll stop here. Thank you.